Everyone to the YouTube channel Spark Research. I am Dr. V, Assistant Professor in the Department of Electronics and Communication Engineering. It's a pleasure to have you all here. In this session, we will be discussing and solving important questions from GATE 2025, specifically from the subjects of PCB and electronics devices. This session is designed to help you understand and concept behind each question, improve your problem solving skill, and gain better clarity on the topics that are frequently asked in the GATE examination. Before going ahead, let me tell you, GATE isn't cracked in the final year. It's built quietly from the first day of your BTech. One concept at a time. Stay consistent now, and your future self will thank you. So let's go ahead in the session. So here is the overview of the electronics devices, the subjects. Here, if you will look into the subjects, the syllabus for these subjects, that typically the questions may come in the range of the 6 to 10 marks. So this is the one of the important topics. You should go through that. Okay, so let's take the question. So question here, it's telling about this. This is 39 number question from GATE 2025. So in the circuit below, M1 is an ideal AC voltmeter and M2 is an ideal AC ammeter. Now there is a source that is your VST, means this is the source, that is why we are representing it Vs, and T is because this Vs is a function of time, and the amount is that 100 cos and 200 T. So of course omega, that is the frequency, is given 200 and T is the function and the 100 is the amplitude. The cosine is the function. So this is something like that. It will vary the cosinusoidal and it will have the amplitude, that is 100, and then frequency, that is given omega is equal to 200. So these are the informations that has been given. Now what is the question? So what should be the value of the variable capacitor C at that RMS reading? RMS means IRMS or VRMS. RMS reading on M1 and M2 are given like 25 and 5A. What is this RMS? So AC equivalent voltage or current, right? So the question is asking what is the value of C, right? So capacitance. If we look into the circuits carefully, then a voltage source is given and M1 means that is being used to measure the voltmeter. So that is why it is connected parallelly also. So the voltage, you will get the voltage here, and already RMS voltage is given how much? 25 volt. And current, here you can measure the current, that also has been given, that is your 5, right? So now question is that here also resistance is given, that is 5, and inductance, that is 1 Henry, and the capacitance is the question, right? So what it will be, as per your answer key given, your the answer option A is correct, means the value of the capacitance must be 25 microfarad. So this is the question. So let's see how to solve this question. Now look very carefully. So here is the inputs already given, M1, M2 is given, right? And values are given. So first we will find out the impedance. Step 1. So impedance, since RMS is given, voltage and current both. So this is equivalent to the AC circuit. So put the values and get the impedance. So once we will get the impedance, so now you can find out the impedance for your circuit, this circuit, and then we will equate, right? So for our circuit, what will be the impedance, like R and R, the square root of R, and then XL minus XC whole square, right? So here means actually this is the resonance condition, and how we'll know that resonance condition? Because already resistance is given, that is how much? 5 ohm, and impedance how much we got, that is also 5 ohm. Means what? Resistance and impedance both are same. Both are same means what? XL and XC both have the reactance of 0. So directly we can write XL minus XC whole square equal to 0. So now XL, like XL is equal to how much? You can calculate omega into L. Omega already we have in the equation, that is omega is 200. So here put the omega 200, L is also given in the circuit, that is 1 Henry. So omega L you will get. Similarly, XC is equal to formula you can use 1 over omega C, and omega already given, that is 200, and C is unknown. So put like both of them you can equate. XL is equal to XC, and put these all these values, you will get the value of C is equal to 25 microfarad. Okay, let's see the more details calculation for this particular question. So step number one, here the VRMS, IRMS is given. So impedance you can find, that is 5 ohm. Now impedance for any RLC circuit, how will you find? So Z is equal to square root of R square plus XL minus XC whole square. So R is given, that is 5. XL you can find out omega L, XC 1 by omega C. Put all these values, and Z already we got, that is 5, right? So here Z is given 5, then remaining terms you can put it. So 25 will cancel out, and you will get XL minus XC whole square equal to 0. So XL is equal to XC. Now XL is nothing, omega L, and omega L you will get 200, and XC you can get 1 by omega C. So put all these values, and you will get the C is equal to how much? 25 microfarad. So that is the final answer as per SLK. This is your option A, right? Okay, let's take the another one question. So in this question, what is given here? All diodes. The question belongs to the full wave rectifier, bridge type of the full wave rectifier. You can see here the 4 diodes are there, and one resistance is in between there, right? So all diodes in the circuit given below are ideal. Ideal means it will have the characteristic very simple, like ideal characteristic, right? So there is input and in nothing, no amount of the current, right, in the reverse direction. So ideal characteristic. Okay, so which of the following plots are is correct when V1 is swept from minus M to M? So V1 is swept from minus M to M. Minus M to M means some minus, suppose 5 volt to plus 5 volt. That is called the the swept from particular either voltage or the in the current, anything you can consider here, right? So let's consider here as per the option we are going to consider. So before going ahead, let us discuss how exactly the current will flow through this rectifier. So for the positive for actually for suppose there are the two cycle, positive cycle and negative cycle. Of course, the output will be something like this. Here both cycle will cross, right? Means positive cycle, of course, this will be the positive one only, and negative cycle also be reversed, and output that you will absorb across this across a resistance that will be similar to this waveform, so positive only. So that is called the Fourier rectifier. Now how exactly this type of the the rectifier outputs will you observe? So input will cross first positive cycle like this, and it will follow this type of route, right? And similarly, negative route, how will it cross? Like this and this, right? So in this way, the both cycle will cross, and you will get the output like this. Okay. So let's see the details. So here, if we will look into these options, already options we have like option A. So check it for this positive half cycle. What will happen? If input is suppose is on the x-axis, that is input is 0 to M, and the output that we are observing 0 to M, that is V0. So for positive half cycle, what it will happen? Your current will be equal to the VI by R, and V0 will be equal to Vi. So for positive, Vi is equal to Vo, right? So here plus M, and M is equal. So that right half is correct. For negative half cycle, what will happen? V0 equal to modulus function of Vt. Means actually what is going to happen here, whatever the inputs we are giving now, the output will have them in positive half cycle also, right? So in the negative half cycle also, your output will be the positive values. So in the left side, even if you are giving the minus M, In that case also we are getting the plus m, right? So these are in the positive half cycle. That is why this option is correct, right? So option A is correct. Similarly, now second one, if you look V into V naught, so here in the negative circle, like whenever we are giving the minus M, then according to this graph, it is telling that your value of the voltage is minus negative. So actually this is not happening here. This is the modulus function. So this option will not correct, right? So this is not correct and this is correct. Now in option C, if you will look, now this is the current versus VI. So current, here, whatever the current is flowing in this case, for the negative half cycle especially, so I is equal to what? VI by R. So negate the current whatever is flowing through the resistance, that will be in the reverse direction. But here it is telling the current will also in the positive direction. This case is not going to happen. So current will be in the negative direction. So again this option is also not correct, right? So in this option current, it is telling that it is flowing through a negative direction and this will follow this rule, right? So that is why this is correct, and so this option is also correct. So answer A and D both are correct. Correct. So here some more details, voltage is crossing like this. So in this case, in option A here, if you will check it, so suppose for positive here, now positive half cycle, what is happening? So for input you are applying on the x-axis. So for negative, of course your output voltage will be positive. So that is why this left one is correct, and the right one, like whenever you are applying the positive voltage, positive output will come. So this is correct one. And for option second, if you will check it here, so here what is that, your current na vi and v naught, this is not correct. Actually this is option B, because your whenever you are applying input voltage, the output voltage will not be negative, right? Similarly for your current, now this is the option C here. So here this one is correct. Actually this one is option D, right? So check the option properly. So option A and D are correct, right? Okay, so thank you to join the sessions. Before going, before leaving, let me tell you: play today, stay healthy tomorrow, and learn for a lifetime. Thank you.